Good afternoon. This is G. Om Kedareshwar Kiran from Institute of Aeronautical Engineering College at the Department of Electrical and Electronics Engineering. Today I am going to present about the brief history of electromagnetism in the electromagnetic fields and how the what is the electromagnetism and its uses, defaults, and all other brief introduction in further slides. Now coming to the facilitating the history of electromagnetism. First of all, what is an electromagnet? In the left side, we can see the picture of an electromagnet having two poles, north and south. DC source of battery is given to the coil. The magnetic field is around the coil because the coil is the current carrying conductor. So now coming to the theory, electromagnetism is a fundamental force of nature responsible for a wide range of phenomena from the behavior of magnets to the working of modern electronics. I- Its study has a rich of fascinating history stretching back centuries and encompassing the contributions of many brilliant minds. Electromagnetism is the physical interaction among electric charges, magnetic moments, and electromagnetic fields. And electromagnetic fields can be static, slowly charging, or from waves. Magnetic waves are generally known as light and obey the law of optics. From ancient Greek to the modern world, how the electromagnet or the electromagnet modern science we need to know. The picture here, we can see the picture here. It is about the what we call electromagnetic core and electromagnet in the modern world. Ancient observation, according to this picture, is ancient observation. Early civilizations observed the power of lightning and properties. Old stone. It is a old stone occurring the magnetic rock. Sorry, magnetic rock. It is a magnetic rock. The marked and beginning the understanding of its electromagnetism. In 17th century, the birth of modern science, William Gilbert, a physician and a scientist, conducted experiments with magnets and electricity, laying the groundwork of future discoveries. In 19th century, unifying forces, James Charles Maxwell and the Scottish physicist developed an undefined theory of electromagnetism, the electromagnety of electricity and the magnetism of a single force. Understanding the nature of electromagnetic fields. There are two types, electric fields and the magnetic fields. In the electric fields, the electric fields are created by charged particles in and exert forces on other charged particles. The electric field is created by charged particles. Yes, in a conductor, there are free space of electrons. When the source of voltage, amount of voltage is given to it, the electric flow of electrons flows through the wire. And coming to the magnetic field, the magnetic field is created by moving charges and exerts forces on other moving charges, and also the responsible on behavior of the magnets. The best example of the magnetic field is a voltage transformer. The voltage transformer is the core and the example of the magnetic field. It through the core, the magnetic field is done because of the coil or the conductor winding. Sorry, the wire windings. And the next one, the Faraday and the Maxwell. The pioneering work of scientists like Faraday and Maxwell. Faraday's experiment tells about the Mitchell Faraday experiments on electromagnetic induction demonstrated the relationship between electricity and magnetism. Maxwell equations. James Charles Maxwell formulated a set of equations and described the fundamental laws of electromagnetism, providing a framework and understanding the force impact on technology. According to these both scientists, we have what we call seen is the work of the scientist laid a foundation for the development of many modern technologies such as generators, motors, and communication systems. Coming to the generators and motors communication systems in the further slides, we are going to discuss about the partial applications of electromagnetism. On the right side, we can see the types of machine, electromagnetic motor machine or generator. The communication of electromagnetism, it is a machine or it is a instrument. Uh, generators convert mechanical energy to electrical energy, making electric mean major source of power. And the motors convert electrical energy into mechanical energy, uh, powering everything from household appliances to industrial machineries, as we know. Yes, the motors are used in industrial applications and the household works. In the house, we use the motors. Next one is communication. Electromagnetism is the basic of wireless communication technology like radio, television, and mobile phones. We all know that the radios, televisions, and the mobile phones are a source of communication where it is indirectly linked to the electromagnetism. Electromagnetic waves and the electromagnetic spectrum. On the right side, left side, we can see the electromagnetic spectrum, the waves and its frequency 10 to the power of minus 4 to 10 to the power of minus 18. We can see all the wave nature and the spectrums applications of it. Coming to the wave nature of light, electromagnetic waves are disturbances of traveling through the space carrying energy and information. And the spectrum, the electromagnetic spectrum encompasses the wide range of wavelengths, including the radio waves, microwaves, infrared radiations, visible light, and ultraviolet radiation, and X-rays and gamma rays. We all studied about the X-rays and the gamma rays and the electromagnetic spectrum. The applications of these are energy. Each region of energy of electromagnetic spectrum has a own unique application for medical imaging to the communication. Now let us know about the modern technology which we are using now in the general use and the medications. First one is smartphones. Electromagnetism powers of the circuit display and wireless communications systems of smartphones, making essential tool of daily lives. Yes, in the smartphones, the electromagnetism powers and the circuits are relayed, in which means the motherboard and the Arduino board and the screen. It is a part of electromagnetism which we use in our daily life. And coming to the medical imagining, the all the medical equipments which are using, it is a form of or it is a part of the electromagnetism, where the medical imagining technologies of MRI relay electromagnetic to create the imagine of the human body, or X-rays or MRI or further anything scans. These all are about the electromagnetism and the electromagnetism forces of the modern technology, how the world is using these technologies of the electromagnetism. They explain thus these types of all the electromagnetic device and the circuits. The future of electromagnetism, challenges and innovations, and coming to the conclusion also. Energy efficiency, developing more efficient and suitable ways to generate the utilization of the electric energy and electricity remains the key challenge. Yes, the whole world is using they are dependent on the electricity, where the electromagnetism is a part of that, and the wireless power transfers, as we know, the Wi-Fi networks and 5G signals and advanced Bluetooth connections. These all are the examples of wireless power transfers. Advancements of the wireless power transfer technology hold the potential of the revolutions of the devices and the appliances in the modern world. Not in modern world, we are using in our day-to-day life all these types of wireless power transfer networks and high-speed communication. Yes, These are having the high speed communications. For example, the 5G network is compared to the 4G, it is very high speed communication. The speed of signal and the bandwidth and the quality factor, these all types of factors depend upon the speed of the communication. Mainly the bandwidth and the frequency depend upon the speed of the communication. The electromagnetism is constantly evolving the meet growing demands of faster and more reliable communication networks. These all are high speed networks which we use in our day to day life, Bluetooth and wireless 5G networks. Yeah, we have discussed all the types of electromagnetisms and what are the different types of electromagnetism frequencies and how they are used in the modern world and how they are still using the modern technology behind the electromagnetism. And also the conclusion is about this, the future of the electromagnetism challenges and innovations. Yeah, thank you.